Oh, we lost 2 people. Hopefully they'll come back. Um, Look, like I said, I mean, I was gonna be happy with 10 people. Um, okay, I'm gonna lower everybody's hands, otherwise we're gonna be lost forever. Lower all the hands. Um,
So
okay, so let's try to move forward.
yes.
Did we manage to solve the problems? How many people still have problems? I think Alex still has problems. Um, Makara still has problems. Look, guys, we will try to get to the. There was some strange humming going on. I'm not sure if you guys heard it. Okay. Sorry, I was saying the. I'm gonna be more professional. Put the microphone in front of my mouth. What was I saying? Yes, we'll try our best to solve all the problems. I guess we're gonna have some more time at the end of this,
Yeah.
and then yeah, we'll just do it afterwards. I think that would be the best thing. Anyway, I give the floor back to Manas, and let's continue. There's a. Should we clear up the questions first? Q&A. Um, could you show the changes that you made to the file? Is that already? Or these
Yeah,
are
yeah. Almost done. Yeah, they're all done.
okay. Then we had one more
So
from Alice. Could you quickly show the edit for the pipeline config, please?
so yeah, I've shared this TensorFlow object detection API tutorial on Teams group. So when you go to
Share the screen.
oh, I
You need
didn't
to
share my
share the
screen.
screen.
Oh,
No, you're not sharing your screen.
so this link on our Teams chat, and if you want to know where exactly we have to edit this pipeline config, you can go to configuring a training job here, and then here is your training config file. So it'll highlight the things where you have to do changes. There, the first thing is here, batch size, increase or decrease based on the memory, the fine tune checkpoints, detection if detection similar to the ones, and then label.txt here, and this one here, this one here. Yeah, it will basically highlight all these important important fields. Similarly with the training, this is the entire official API that we can that you can follow step by step from your installation part to your data labeling, everything. This will include image labels, uh, everything what we have learned today. This will have everything in documentation, right? And yeah, for those people who are installing TensorFlow on GPU, want to install on GPU on your laptops or desktops, you can use this step-by-step procedure to do that. So today, it's more about implementing all this on Google Colab, which usually you couldn't find a better notebook that does everything on Google Colab, because using GPUs are really frustrating. So I thought, why not let's make a workshop directly on Colab itself, so that most of the people will have access to it and then can try object detection API. Usually it's definitely not possible on a CPU. Okay, moving back to our workshop. So we are still training this thing. So we are at 4,900 steps. So yeah, again, 5,000 steps. I'll quickly go to the Tensor board. Here you can see my graphs. Okay, classification loss, localization loss, regularization loss, and this is our total loss. So I'm gonna expand this total loss, and now zoom it a bit. So I've trained until 5,000 steps, right? The loss is still going down. That means model is still trying to learn things, right? We can definitely increase our training time and make sure it touches as low as possible. However, I'll training for now. Let's just check what the model has learned until now and make it like a say it's a final model. Suppose say you have reached the last point and you want to stop the model. So let's go back to our notebook. For stopping, you can just simply stop. Simple as that. However, when you go to the training checkpoints folder, that is where all your checkpoints are, right? This is your model that you're training, and if you open that, this is all your checkpoints. As I told you, only 8 checkpoints are going to be stored, rest of them are deleted. So we are still under 5,000 marks. So that means the first checkpoint is default, the second one is around 1500, this one is around 3000, right? And this one is around 4500. So at the moment this checkpoint is for 4500. So if I stop training right now and use this checkpoint, that means I'm stopping the training at 4500 itself, not 5000, because at 5000 I haven't saved my checkpoint yet. So either I can wait and until next checkpoint, or I can simply stop. So at the moment I'll simply stop it because I think it's fine. It's okay. You can simply stop this. So that stopped. See, that stopped. And 1 second. Wait. Just give me a second. My laptop has frozen for some reason. Problems of Windows users. Oh, I think anyways the runtime is deleted, so we'll just restart. 1 second. Close everything. Okay, this is a different project. 1 second. Let me go and use this account. Use this. One second, guys. Yeah. So now I'll just quickly connect. So let me try this mounted. This. So I don't have to clone all these things. They're already in the background. Let me check if I have this thing as well. It all run. It's done. Let's go to this. It's done. Let's do a setup. Oh, it's already installed. Okay, we don't have to build this every time. So we already have all the checkpoints from the training. So we have saved those checkpoints in our drive itself. So even if you lose the connection just like that, you don't have to worry because training data is saved in the drive. Let's jump directly to the exporting part. How do you convert this checkpoints to a model? So I've shared a script which basically converts this thing, which is convert to saved model.py. So always remember uh, the model end format is always going to be either .pb, right? .pb, saved model.pb. If it's a JavaScript model, it's going to be .js. Similarly, for PyTorch, it has its own extension. And similarly, YOLO, it has its own extension. So the TensorFlow object detection one is .pb. So even when you downloaded this SSD mobile net, this model, when you open that, you have something in this structure, right? Which has all the checkpoints, and it also has a saved model.pb. So this means it's a final build. So right now what we have to do is convert our training checkpoints similarly to that format, so that that model is going to be our the final model. So let's open the script from here and drag it like this. So yeah, this bunch of documentation, this script is directly from TensorFlow. I think I haven't done any modification to it. Yeah, it's a pure TensorFlow script from the object detection API itself. Nothing modification done. I've just changed the file names, and so this script will take inputs. So this first one is input shape. So we are not messing around with the input shapes because this is extremely difficult part of setting up this save model.py. The right now whatever we have is already set for object detection and key point estimation. So these two things, it's already set in within these tools, within this thing. And I also think I don't think any of the models will require a different input and output shapes other than object detection. So almost all the models are for object detection. And here we specify our here we specify our model config, which is our config file from here. SSD mobile net, this one, config file. I'll just copy this, copy path, and I'll paste this. it's not the same one. Just to make sure, Control V, Control C, and then delete that thing. Okay, that's our config file done. The second one is trained checkpoint directory. That is the one which we basically trained checkpoints with. So this is our trained checkpoints. I open that. I give the model name. So I gave a model name this one. So I'll just copy this, copy path, just the model name, and give it here. And again, delete this the back thing. Yeah. So now what's happening is it'll automatically search for checkpoints, the latest checkpoint from this file. So all you have to do is put a slash so that it will check all the files after that folder. Okay, so inside that folder, and the output directory. Now we need an output directory. Suppose say I want an output directory. The output directory is trained models. So here we have training checkpoints, pre-trained models, so we can use trained models. Just refresh it. So trained models is empty right now. Trained models is the models that we trained. We are using this folder to save our models. So we simply put, we simply put the path there. Copy path, and we put it here and delete the rest of the thing. What you can do is here, so once you specify, can you guys see my screen properly? Yeah. So once you specify this folder, trained models, it's trained models. My bad. Let's copy it again. Copy path. Control C. Train models. Slash. You can give any model name that you want to give. Just like you've given hat 0001. This thing, I'll probably give the same thing as well, because I would know what that particular model is trained on. 001, batch size 8. So that's my model name. And yeah, that's it. Nothing more. Just inputs, config file, input your checkpoint, input your output your model. And when you run this, it's going to slowly create the model and give us the model file within our trained models directory. You will find so many warnings and something like unsupported, something like this. That's all still fine. It's just that few tensor shapes may not convert properly, but then TensorFlow will optimize them and convert them. Yeah. So that's done and saved. So right now, when you open trained models, you would see this mod. And this has the similar ones which we have for SSD mobile net. It's this, checkpoints. You open checkpoints, you have the latest checkpoint. Save models, you have assets. So there's nothing in assets, that's fine. So variables and the saved model.pv. It also have, it just basically copy pasted the pipeline.config over here with the changes that we made, with all the batch size, all these changes that we made, it basically pasted over here. That's it. That's how you export models to, export your checkpoints to your models. Very simple, just one script, done. Now comes this inference. Now, how do you test that your model is working, right? That's a really important part. And how can you run your models in real time? Yeah. So what I'll do, there's a small script. It's a small Python script. I'll go through the script. So initially, import OS. Or you guys know the OS thing. It'll basically collect files from your operating system. Any read-write operations can be done using OS. You're importing TensorFlow. Uh, you can skip that actually. Pathlib, it's a dependency package. Google, CV2, we can use it on the desktop or a laptops, Jupyter notebooks, but Google Colab doesn't support CV2. That's because the output of a CV2 is a window, right? It's a pure window, and we cannot open any windows on the web browser. So that's the reason we cannot use a general OpenCV. So we have to use a collab version of OpenCV, which is CV2 underscore imshow, just one package. This is uh, so it's a GPU programming. If you want to do an inference on the GPU, so you need to make sure that you set your memory growing so that your entire GPU is not allocated just for doing this job, right? If you have like 10 gigs of memory and you're using 10 gigs of memory just to do video streaming, that's a lot of a wastage, misusing of GPUs, right? What So this will ensure that if your image takes only one gigabyte of processing, so it will only allocate one GB of GPU for whatever your code you're running. It won't allocate the entire GPU. So that's a huge problem, especially if when I'm using Deakin server, which has like 10 GPUs, and if another guy is also using all these 10 shared GPUs, if he doesn't put this one, or maybe most of the GPUs are allocated to him, even though if he's not even using them. So that's a huge problem. Some people miss that, but I just wanted to add it so that the other person who's using that GPU is happy and you both use together. Uh, so here, all we need is to provide the model file, the model path. So simply let's go and train models here. Here, saved model. Just copy the saved model thing, copy path, and then put it here. That will automatically find the saved model on .pv file because it's on the same folder. Now we give label underscore txt, which is our classes. So these classes are on here. They simply say if you get an output 1 for hat, so it will simply say 1 is head, or simply 2 is helmet. So the outputs are always going to be numbers, right? So it will convert numbers to text for displaying. Yeah. Oh, I've just noticed one small thing. I think I have to delete this one. That's because I'm adding the saved model here. So it's like this path plus saved model is the final path. Or it's it's fine. Like, or I'll just let's keep it that way. No problem. And yeah, I can. Can I? Run it. So yeah, so we have loaded the models. Whatever the model that we created, we loaded that model at this name. So this is the function tf dot saved underscore model dot load, and you give a path to the pb file. So this exact folder, you need to give the path here and use this function to load your model. And if you pass an image to this model, it will give you a prediction output. I'll show how this prediction output looks. Uh, Before that, we just loaded the model right now, and as it took around 8 seconds just to load our model. And this is only one time, right? The second one is you read an image, you pass this image to your model and get the predictions out. So yeah, we are importing some basic libraries, NumPy, Matplotlib, and few warnings to check what's happening with the we are basically ignoring all the warnings. That's fine. So there is a function here which basically loads a NumPy array, load an image file into a NumPy array, because at the end of the day, this whatever the file that you are using, you need to convert that into arrays, right? Models will only accept image tensor, shape of an image tensor, and image tensors can be created only using arrays. So now we are converting your image to array using np.array of image. That's the entire image. And now you are simply converting them using convert to tensor. And once it is converted to input tensor, you're passing it to the model. This is the model, and you get the detections back. Uh, I would like to basically run this and see the output. Okay, so that's the detection. So these are all the detections that you get from running. I know they're super complex. I mean, there's so much data just for one picture, but I'll break down what exactly this information is. Okay, so these are the detection scores. I mean, this entire dictionary of detection scores is for 100 boxes. Okay, by default, model is going to predict maximum of 100 boxes. So even if there are 4 people on a picture, it would still predict 100 boxes. But only 4 people, only 4 boxes will have higher confidence. The rest will have very least confidence, right? Uh, same that thing. It provides 100 boxes, and then it gives anchor points, anchor indices. That is no, we actually don't need the anchor points. Yeah, detection score. This is the detection score of each box. So that means the first box is detected 99%, second is 99%, third is 99. And when you see the fourth, fifth one, now you can see the accuracy goes zeros, right? Almost zeros. So that means all the heads and hats are already detected here, right? And the rest of all are random a very low random digits of epsilon, value of epsilon. And these are the bounding boxes for each box. So this is for the first box, uh, and this is nothing but this score, this box, and this score, the second box. You can basically map it, right? It's in the serial order. All the things are in serial order. Now comes is the class. So these are all for 100 boxes. Detection multi-score class. Oh no, the multi-class code, we can skip that. There's so much. Yeah, detection class, we need this one. Two, as you know, two is basically helmet. Two is helmet, and one is head. So depends upon the confidence, you need to filter them uh, based on the, I mean, the thresholds, whatever whatever threshold you said, suppose say 70% as your threshold, you need to filter all these values using score as 70%, and then you will basically remain with only 5 or 4 detections with all as hat or all as head based on that. When you go down, that's it. That's done. Let me visualize this. Just a second. How can I visualize this? Okay, I'm just so now that you have seen the detection and all the results, that's how you get the detection results for all the TensorFlow object detection models. It's same for all the object detection models, and that's the format, in fact. And now here we have to display stuff, right? To display stuff, I'm just using this package, TV2 ImShow. I'll just put it over here and open it. And this is the file name uh, that I'm passing. I'll explain this, the visualization part after I do this. I'll just put it here, run it again. Let me see. So yeah, now you went into, I mean, you got the detections here. You pass the input tensor to a model and you got the detections, right? Once you get the detections, you are now basically getting the number of detections. So now you have 100 detections, right? This is the 100. So you can see the int 100, you can see the value there. So there are 100 detections, and you're also going through each detection using items. So items is nothing but, one second, it's a little complicated one. So uh, oh yeah, so you just have two classes, right? You're iterating the entire thing based on your items, and at the end again you get the same detections back. So from these detections, you're basically saying number of detections 100, you're just copying them back to number of detections so that you can pass the entire dictionary over here. We know we have to convert this into integers. I mean, you have to do some type data conversion, because whatever the current data is in float, uh, you can see, right, in the detections it's dot something. So it could be minus, it could be, so some values are in minus, some values are in plus, but this will ensure int64 will ensure they're all in positive integers. And yeah, and basically you're copying them again like this. This visualization script is again by TensorFlow. You can still write your own scripts using OpenCV. You can use NumPy, Pandas, and all these libraries. Just all you need to do is you need to know how to use this detection data. So whatever the large data I've shown you, you need to know how to use that, extract the data that you want, and use it for drawing boxes or drawing circles. You can do any stuff with that, with those things. Okay, so I've drawn these things. So this will take boxes as input, classes as input, score as input. It'll do all the, I mean, necessary calculations. It's a very big function. You can still, this is your minimum threshold. If I put 70% here, 0.7 is 70%, and then run the cell. So only the images with are above 70% are displayed. So that's still okay, not I mean accurate. I would say that's because this image is from the training set itself, right? It's no big deal. So I just took an image from the training set. Obviously, it's gonna give us 100% super good results because it's the model has seen the picture. Let's now try some picture from online. Had construction hat, construction workers or anything like that. Let's see. Oh yeah, let's see with this one how we go with this one. Uh, Save image as. Let me just see. Test. Downloads folder. Save them. I'll just try to upload this one. Uh, where can I upload this? I'll simply upload this in the file itself. So I'll just do this one. Upload. Test. Open. Yes, that's fine. Where is it? Test, 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 test. Is this the image? Yep, that's the image. So right click, copy path, and I have to copy this path over the image path, right? It can accept PNG, it can accept JPEG, it can accept all these image file formats. That shouldn't be a problem. So yeah, it's still accurately giving. I mean, yeah, that's still fine, right? That's still fine. Let's find some other images just for the head. People. People. Yeah, I mean, definitely not sure if it's going to handle, but let's check. Yep. And I'll click upload. Just Control V. There's this guy here. Copy path. Oh, it still says helmet. Let's see why. So the one is never an option. So this means the classification loss is not that great, but the regression loss, I mean, finding the bounding box is good. It is able to recognize the head and draw a box for it, but it is not good at recognizing what exactly, I mean, what exactly the person is. I mean, the classification is. Uh, Maybe it needs a bit training, or not sure why exactly. Uh, yeah, why exactly that thing is. Also to remember, we just trained this thing only on 50 images, just 50 images. Uh, but still, I would still say at least the bounding box loss is really good. Yeah, may not be classification because that's a new thing. The model doesn't know what's helmet and what's head before, but model definitely knows how to detect faces. So it did its work right. Probably a bit more training and bit more data, we could really get this really accurate. Yeah, I also have a really good accurate model already trained a couple of months before for a different purpose. And yeah, next I will basically upload that model and show you guys really good results on on that model. Uh, can you try maybe a cat or a dog image? Yeah, sure, why not? Cat image. Let's do this one. Oh, that's too small. Let's do this one. Oh, sorry. Save image as. Let's do. Oops. No. So that's JPG. What we can do is simply entity file. See, yeah. Uh, at least it did. It didn't recognize it as a human. But yeah, it definitely needs a lot more training and a lot more this thing. So next I'll show you how we can run a model on a video, on a continuous video, right? So this is a video that we used for our prototype for making, I mean, yeah. So it's a really long one. Yeah. So the entire video is on AWS as a .mp4 .mp4 format. What I'm simply doing is just copying that link, whatever the video is in on AWS. I'm using cv2 dot video capture function in OpenCV, and then uh, obviously I cannot display this in real time on Collab. However, it's really easy to do it on our Windows machines or Mac machines. But on Collab, what we can do is we can run detections on our model and create a different video with the detections on it, so that we can just download the video and then see what happened with that detections, right? Uh, so this is there, and I think we are good to go. I'll just simply click on this. So for every frame, it's going to do that thing. So every frame it's going to take a prediction and like get the results, draw the bounding boxes, push it to a model, right? I mean, a video writer. So we are using a video writer here, which is this cv2.video writer. It will write every frame one by one, one by one. So meanwhile that's done, what I'll show you is the shared, I mean, so this is one model that we created for a client. It's the same, I mean, the purpose is the same, to detect hat and wets, but it's trained on much more images, at least like 4,000 to 5,000 images, and fairly accurate, I would say. So let's use that model to see the predictions, how we are going with the predictions for that for our thing, right? So I can access these models here. They're here. Yep, I can access them here. I need to make sure that if I have to set this within this project directory, so I'll just go here, this one, I'll drag drop inside that, just went inside, and it's over this. So let's go back to the file. Just refresh that like this. And now I have had detection, all these things here. I can simply use this particular folder to run my predictions on. This has all the necessary files that I need for a deployment. It's taking time. We still couldn't see the output file here because it's a drive, and you can only see once the entire thing is done, and then it will be uploaded to the drive. But we can see that file here. It's around 300 MB so far, so I'll just stop it for now. That's too much. Okay. Let's download them. Oh, might take a lot of time. Or just close it like this. And see it over here. Yeah. Hopefully we can play AVI files. Oh no. Not anyway. Yeah, at least this is fast. It's in slow motion. That's because of the writer. We can increase the fastness of that. But yeah, obviously the results are really poor because it's a. I mean, we have just trained it with 50 images that to only just 5,000 steps, right? But still, for some parts of the video, we can really recognize them for every frame, at least the bounding boxes for every frame. Yep, it's done. Let's try with my oops. It's a much bigger model. Maybe I've never tested it on Collab. It's a much bigger model. Let's see if it works or not. Oh yeah, 28 seconds to load. Not bad. On a cat image. So cat image, it didn't give any predictions, luckily. Let's try with test. Oh, where is it? Test.jpg. Please continue. Yeah, sure, I'm there. Head. Oh, that's bad. 1 second. Probably it's the problem with uh, the uh, I mean, my model might have one as head and two as helmet. Let's see if I get helmet for the other one of this guy, then yep. Oh, for this we didn't even get anything. Okay, that's weird. Or let's just delete this one. Delete this one. Yep. And try to run it on that. It's done. Oops. Oh yeah, it's the same issue. So the helmet is basically classifying as head. That's just the label difference. So one became two and two became one. Except that it's yeah, that's fine. We can always change the those labels before we, I mean, specify it for a label.txt there. So we can simply change that in here. So we can put it this 0 and then put this to 1. If we have detection outputs, this detections. Okay, it's 1, 2, and 3. So there are 3 classes for my model, not 2 classes. I'm not sure what's the third one, but this is 1 and this is 2. Save it and run it on test. Yeah, unfortunately, I have to load the model again because it's going to take this as input. Oh, maybe not, but let's see.
So maybe
Yeah,
what happens, maybe we can try to see if anyone has any questions
yes, yes.
about this part. So let's try to optimize the time. So Arun was asking, was wondering if instead of fine tuning the whole pre-trained model, we freeze the initial few layers and fine tune on just the last one or two layers, fully connected ones.
Uh, Unfortunately, this API wouldn't allow us to do that thing. But if yes, if we have our own models, then yeah, we can do it. Not with this TensorFlow object detection API. Or maybe I haven't seen that. I mean, a part where we can disable training for the initial layers. But yeah, I will do some research and let you know if we could do it using API.
Did something come
And
out already? Or
yep,
oh, okay.
yep. Anything else? So converting these models into TensorFlow JS models, I'll yeah, we'll discuss that tomorrow or day after tomorrow once you guys are familiar with this object detection thing. We'll see and deploy them as TensorFlow JS models. And you guys have any questions?
Okay, so can you go back to the image of the guys with the helmet?
Yeah.
Okay, so this is probably the big question that comes up. What is the meaning
Mhm.
of the number? This is a
Oh,
very important question.
so the number is basically how confident that picture is. So that box is 80% confident that it's a helmet, and it can literally change. I mean, we can literally change the number just by changing the label, and it will simply say it's 80% head. So in data science, these numbers are what you, I mean, how you visualize them. So what I would say is it's just the score, the bounding box score or the classification score. I can simply put bounding box score as 80%, and people can literally see higher accuracies here. But what we need is the classification accuracy to be here, which is 80% helmet or 90% helmet, 80% head or 90% head, something like that.
So this is an actual. So this is the confidence. Yeah. So this number is very important when you need to explain to people um, what it is that they're looking at.
Yeah,
Um, so so the score, meaning that if the model says it's 80% confident, um, it doesn't really translate in 80% chance that it's right. Um,
yeah, not in real life.
yeah,
It's just that on that particular data set. That's it.
exactly. So
Yeah,
one thing that you need to do then is to set up your own type
benchmark.
of test. Somehow you need to go and test it yourself. So how
Yes.
would you go and test it? You would go and actually, pass some new images and look at
Yeah.
them and say, um, how many false positives or how many false negatives do you get? That is the score that you kind of need to deliver to your client if you need to, do something for a client. If a client
Yeah.
comes in and say, I need an application that 90% of the times can find a cat in a picture, you can't go and use this score to say, oh, our algorithm reaches 90%. It's not that.
Yeah.
A lot of the normal people, yes, a lot of the people will understand that your score of 90% means that 90% of the time you can find the right one. It's not.
It's not.
To get a score like that, you actually need to sit down and test it and see in real life what is your actual score. 90% means that you put through, I don't know, 10 pictures of cats, and at least 9 times out of 10, it recognizes there's a cat in it. That's
Yes.
what 90% means.
Yes. And even the state of the art models, when we go to the object detection API, and when we go to the model zoo, which is this one, you can see the accuracies right here. The maximum you could see is 50. There's this 50, and that's considered as the top line model. I mean, it's literally the state of the art this year on the Coco data set. That's because, yeah, the accuracy number for this particular thing is just that much. The images that has is really, really huge. It's a really huge data set. Uh, so the labeled images are around 200, but in 200 in all these 200K images, there are 1.5 million objects. So whatever those small objects, one hat, one head, there are 1.5 million of those things, and they're classified as 80 categories. And yeah, so on this data set, that accuracy is good. People try to compete with, I mean, if I say, if I get 45% accuracy, if I say someone who's not from data science, he would literally say that's a fail model. But if I say 45% accuracy on Coco data set, or to a data science person who knows what is Coco data set, then that guy would literally say it's an amazing model, right? Yeah,
Okay,
this is by
we have
this one.
more to talk about in the inference part.
Yes, Alicia.
No, I mean, we reach the end of the inference part?
Yeah, we reached the end of the inference part. So this one is just for the video,
Mm-hmm.
but later on I'll show different techniques to how to use those boxes. Now, now say you just got the bonding boxes. Suppose when we are dealing with perimeter detection, suppose you want to draw something on a picture, and you want to check if a person, you're drawing a bounding box for the entire person. You want to check if that person is on a restricted area. So now what you do is you have 4 points, these 4 points. You calculate the center point, and consider that as foot of the person, right? Now you locate where exactly this foot is uh, within the box. So if it is in the box, you simply say the person has stepped onto a restricted area, and if it is outside the box, you simply say you won't trigger any alarm. You check that using bitwise operators. It's more OpenCV. Uh, you will get to know once you use OpenCV, all the functions of OpenCV, and all. You'll easily get to know how you can manipulate these results to fulfill our task. Yeah. So I think, yeah, for now I will definitely not go much into uh, the implications of these proper detections, because it for you guys, you need to come up with ideas, and if that particular idea needs a specific say very, very specific thing, which can be done only using computer vision or OpenCV libraries, then I'll definitely help you guys what needs to be done on top of this detections. I think the important part is idealizing your problem, and then thinking as a data scientist and collecting data, labeling them, putting it into training, and getting the model. So the idea part is the most important part.
Yeah. So I think what we need, I think one thing that we never mentioned is that is very important is also being able to engineer our ideas. Um, so unfortunately, there is this, concept that um, we have infinite resources. Once you get into data science, you will understand one thing: your infinite resources are extremely finite or finite. I can't remember. Finite resources. Um,
Yeah,
so
very
even
limited.
having you can go out and you can go buy an Nvidia 3090 just to realize that it will still take you hours to train a model. um,
Yes,
the models that we train for our system, we train them on the Saruman system, which has how many GPUs?
eight GPUs, and each GPU is 12 gigs,
Yeah.
and it has a RAM of around 128 GB. It's a
So
40 core processor.
yeah, so you think that that would be, you could do everything on it. um, that's definitely not the case.
Yeah,
um, and when we actually make, so that's the training part, so that's that's what we need to see when we train, which is fine. We're looking at a lot of data. But the other problem is when we create application and services. Imagine if we had to create an application that was needed 8 GPUs in parallel to work. That would be extremely, extremely expensive. um, So at our level, we're looking at perhaps to try and use the minimum amount of resources um, to make things happen. And so we really need to play with everything, and we have to think about how to engineer our things rather than let's just increase the resources. Um, and I think the clearer example was when me and Manas had to solve the problem of multiple models coming in. Multiple models being applied to the same image.
yeah.
Um, what are the things beyond the data science that I can go and touch to go and solve that problem? For example, do you need to do um, real time on a video of 24 frames? Perhaps you don't need it. Maybe you can just do 12 frames. Or I can't remember. Manas, do you want to talk about one of the things that we solved? Uh,
Yeah. So few more. So we've run four models parallelly. So one is for estimating head detection and hat detection. Second one is the vest detection, construction vest. Third one is to check if a person is running, fallen, or a perimeter detection. That's the third one. And the fourth one is a deep sort algorithm, which is, suppose say you got three bounding boxes like this. Uh, One second, guys. Suppose say you got three bounding boxes like this, but in the very next frame, you still get the three bounding boxes because there's no much movement, right? However, you need to know that this bounding box is the same person. There's no assigning of IDs for these bounding boxes. So the first bounding box is not always this person. It's always the highest confidence, and the confidence can be randomly done for every single frame. So in order to keep a track of the bounding boxes, we also used a deep sort algorithm for that. So that's four running on single GPU on a single image at a time. then we face so many issues that the first model takes a lot of time to get the results compared to the third model. We have tried parallel processing of all the four and then getting the outputs, but then uh, by using these parallel processing, Python parallel processing functions, uh, they cannot take our entire model as GPU model, uh, like a parallel inference. So we need some GPU parallelization for that. So what I've created is, so you guys saw this, right? So this small 3 lines of code literally changed the game. So what I did, I I took one GPU. I've created I created blocks, logical blocks of GPUs, suppose say 4 logical blocks, and allocated each logical block to one model so that it treats that logical block as an independent GPU. We can get that thing on TensorFlow GPU.
Okay. I think I just wanted to basically say
Yeah, yeah,
that in data science, you always need to keep um, a good data scientist is a person who can solve a problem. A really good data scientist is the one who actually, I mean, sorry, a data scientist is a person who can solve problems with perhaps knowing all the variables and applying his knowledge. A really extremely good data scientist instead is a person who has to face problems that he has not faced before and can come up with the answers. So that comes from experience, that comes from creativity, that comes from passion as well. And so that is a difference. So that's why I think Manas is really great. He still can grow. He definitely has to grow a lot.
yeah, a
Um,
lot.
but he's on a way to become, really good, which we hope he will. At least I hope. Um, anyway, so I think we got to the stage where we need to start wrapping up. So let's come back to like a Q&A kind of thing. Um, would anyone like to come and actually ask questions? Maybe this time we actually do it as speakers. So what I'll do, I will enable everybody, so you can just come on screen and talk. I mean, we're here to discuss things. And I think,
Yeah.
Manas, you can stop displaying your screen.
All right. Yeah.
So now everybody can come up if you want. Just gonna enable everybody. I don't even know if we can enable everybody up here.
I think it has a limit of 4 or something.
I don't know. I'll put everybody on. Let's see what happens. Okay, so Arun, any questions, anything, any feedback? This is the first time we run it, so
Yeah, I mean, this was really great. There were a lot of information, when this. So my suggestion, of course, this is very good. Suggestion would be like, I think everybody would agree that we could split this into two parts. For some of us, it was, too much to digest. Although it was, a lot. I mean, see, I understood it. I mean, I'm really grateful that I joined this today. And I met a couple of people, made friends, so that is really good. Yeah, so really looking forward to uh, working in this week for using this TensorFlow. My one question is that are we bound to object detection API, or can we use any other methods as well? I'm assuming it will be object detection because we have learned that just now.
um,
You I'm super happy if you use Detectron 2 or YOLO V4, because I've tried Detectron 2. I've trained a couple of models. I've built it's on PyTorch, right? So I'm not from PyTorch background. So right from my initial stages, I started from TensorFlow. If you come up with a model from PyTorch, I'm happy to learn. In fact, yeah,
Okay.
that'll be amazing.
Okay.
yes, I think Arun, just to touch on what you mentioned, yes, we agree.
Yes.
I think, uh, actually, when we started talking about this, we didn't want to do object detection. We wanted to do image segmentation, which is even
Yeah.
hard to just explain what image segmentation is.
Uh,
And
it's one or 2 months project, so it's a really really big one.
yeah, so we went
We need
back
to
to cats and
classify
dogs.
every single pixel, and there's so
Yeah.
much autoencoders, deep neural networks involved in it.
So
Very
we went
very
back to cats and dogs, yes.
yeah.
And but what we decided to do was, since we have people who actually have knowledge, um, yes, like you said, you definitely we needed more time, which maybe we will next time. Um, we are assigning, every group will be assigned one person from our team so that they can get all the support. So then no one is starting from zero. I hope, because otherwise I'm going to kill the people in my team. Um, so that should give everybody the good conditions to start. Um, so yeah, anyone else would like to say or contribute or ask questions? We have people who wants to chat. Let's have a look at the chat. Chat. Oh no, we just have people smiling. Um, okay, yeah,
Hi. Yeah.
Atala, what can we do?
Yep. So I was just asking the notebook, Colab notebook the Manus has been using throughout the tutorial. Will it be available in the resources, or can you provide the link in the team?
Yeah, I'll
It's
provide
already
the
on Teams.
link in the Teams. Yeah,
I
it
just
should be on
checked
the
the
Teams.
GitHub link you have provided, but somehow not all the things you have done in this notebook are done in that notebook. Am I right?
Yeah, I'll share this same exact notebook that I'm using.
Yeah, if you can.
Uh,
Yeah.
yeah, yeah,
Yeah.
sure, 100%.
Yes, Emily, like I said, we 100% agree. So there is a story behind this. So there is a story why we ended up doing this. We were not supposed to run this. We were supposed to work with a company called this um, Data School, or the School of Data, and they were supposed to run it over a week. Unfortunately, because of COVID and everything, they pulled out the last minute. So me and Manas had to go and come up with a plan.
Yeah,
And this was the best plan we could come up with. But look, I think what you guys could do is, you have all the information. I'm going to publish the video. You have all the support in the world. So please use the chat in Teams and everything. And simply maybe spend time tomorrow to go through these things and ask questions. Um, don't worry too much about how do you make it work for your project. Think
yeah,
about what problem you want to solve. If at the end of the week you can come up with a simple, even if you come up with a paper prototype that doesn't really do anything, and then you show us, but at least it gives us like an idea of what you want to do, that's fine.
yeah,
Um, we also want to know that you understand the theory. And look, realistically, what we want to do is, we will really love to see some people to maybe come up with the idea, and perhaps next trimester, um, come back to Launchpad or wherever, and try to really put it together as a real project. Um, because this will be the first thing that you'll be asked when you go looking for a job. They will say, "Can you show me a real project?" So instead of showing your usual, small application that you made during your classwork, this is actually your own stuff. This is supposed to give you the edge. So yeah, that's pretty much it. Anyway, we got plenty of time. We got 1 week. Um,
yeah.
cool. Um,
I've
yeah,
shared the
yeah.
link for that one. Yeah.
Okay, all right. So how do we want to move from here? I haven't thought about how to make projects, how to make the teams. Um, so do we have some people who already have discussed around and would like to um, work as a team? Yes.
We used to have all these small college gangs, and before even like attending the workshop, we used to decide our teams and join the workshop.
Yeah. I think that was happening before as well. So, and look, guys, do not be afraid of not being able to code or, you know,
Yeah, it's
enjoy the week.
90% 90% the idea and 10% is the coding part.
Yeah. So, I guess what we can do is probably maybe we can take this offline and we can just discuss things tomorrow. So what I'm gonna do is in the Teams channel, in the Teams chat, I've actually created a Teams channel. So for Deakin, so the best thing would just be to maybe have our teams there, so that we can easily jump in and out, store the files, and just keep the discussions going. Yeah. So does that sound like a plan?
Yeah.
Is there a way to say no to things? Oh yeah, there is.
There is.
All right, give me some thumbs up or give me some ideas. Wrong chat. Okay, I have no idea. Okay, I guess we assume that everybody is happy with the idea. And look, guys, if you know, if you haven't been able to break the ice, I know this is not really simple. I would have loved to have some sort of icebreakers, which I do in normal circumstances. Unfortunately, I don't know how to do them online. Maybe we just randomly make teams of the people who want to continue to do this during the week. So yeah, I guess that would be one way of doing it. Anyway, all right. I'm gonna stop the presentation. The tables are open until 6:30, I think. So,
Yeah.
or 6:15. I need to go and walk my dog. So that's definitely one thing I have to do. But feel free to stay, talk, discuss, chat, do whatever.
Yeah.
Okay.
Sure.
And I think this was being streamed on YouTube, so this is definitely on YouTube. All right, guys. I'll see you all. If you guys want to participate, we're going to be open tomorrow. So I really want to take at least 2 good teams to the end on Friday. All right. I'm going to stop it.